Hello again, this is Everard Junction, and I've decided to call this video Power and Control. This video will hopefully answer some of your questions. I get a lot of questions about the general sort of power related things to do with the layout, like what controller do I use, what's a bus wire, how do I power the lights, how does the coach lighting get its power, various questions like that. So I'm going to try and sort of round off as many of those questions as I can. This isn't going to be a how-to video, I'm not going to show you how to do anything, but I am going to give you a description and show you sort of where the wiring on the layout goes, and sort of roughly how the whole scheme of things is wired up together. So just quickly before we get started, regular viewers know that I've been working a lot on my coach lighting. I've recently completed another rake of coach lighting, and that is the Network Southeast rake here that's nearest the platform. It's a bit difficult to see because it's being obscured by the platform canopy, but you get a rough idea. There you go. The camera picks it up quite well actually. It's not too bad. I will be lighting the platform canopies as well before you ask. So at the moment I've got 4 rakes of coaching stock lit up. I've got the Hornby Mark IIDs, these ones over here, they're all lit up. I've got some Bachmann Mark 1s in Intercity Exec livery. I've got some more Bachmann Mark 1s in Network Southeast livery, and there's also the HST, which is currently underneath the layout. You can just see in the centre of the camera there the lighting for that, just as it sits in the fiddle yard. There's various other bits and pieces I need to add over to the TMD as well. So that's where I'm at with the lighting. Okay, so we'll start at the beginning with where the track gets its power from and how I actually drive the trains. And basically I use a DCC controller. This is quite a large layout. When I decided to build it, I was going to go with DCC all along. Not too many people use analog anymore. Analog has its advantages. It's relatively cheap and it's very good in small layouts, but when things get big and complicated, it's actually easier to go with DCC rather than trying to wire up all sorts of isolating sections using analog. So this was always going to be a DCC layout, and the controller I chose to use for it is a Lens LH100 system. Now, when I started building this layout about 4 years ago, there weren't that many systems out on the market. There were a few. The big players were Lens, which I have here, and Digitrax. Hornby had just brought out the Elite, and Bachmann had done a similar sort of thing with their Dynamis system. Those two systems were actually very good, but at the time there weren't really any reviews, not many people had them, they hadn't been out very long, so I played it safe and I bought myself a Lens LH100 system. This controller is relatively advanced. It supports a lot of features and it is quite difficult to get used to using. Some of the ways it displays things can look a little bit weird, but you know, I've had it for 4 years now, so I'm fairly sort of happy with how to use it, and I'm very pleased with it. It's a very solid system. We have all sorts of extremes of temperature up here in the attic. You know, in the winter it can be -8, or it can be like it is today, where it's about 26 degrees up here, and the system is quite happy just being sat up here. Every time I come up here, I turn it on, works fine. This is the actual brains of the system. Not many of you will have seen this. Those of you that are familiar with stuff like the Hornby Elite and the Hornby Select, things like that, you're familiar with sort of all the electronics being kept in the handset. You have like a controller that sits on your baseboard and all the electronics are inside, and you have buttons on top of it to push and, you know, make it do stuff. Whereas this has what is basically a separate sort of cordless command system that sends commands down to the actual brains, which is the LH100 box over here. So power comes up to the layout from downstairs via this 4-way extension cable, and then here we have to plug the lens, and it comes down into this power supply here. Now again, the sort of beginner level, entry level, cheaper controlling systems tend to have a sort of built-in power supply, or they come with an external one that's usually up to the job. This is a relatively large layout, and at times I can have 6 trains running, so the Lens system, being designed for larger layouts, doesn't come with a power supply. You actually have to buy a power supply separately and hook it up. Various power supplies you can use. I played it safe again and bought a Lens power supply. This is quite a juicy, quite powerful power supply. It's capable of just shy of 5 amps which is more than enough for the layout and the size that it is. Some of my trains do draw quite a bit of juice, particularly the Helljam locomotives. I mean, under load, it has been known for some of those locomotives to draw quite a few hundred milliamps. So it's important that you get a power supply that's going to be meaty enough for your layout. So from the power supply, it goes into the command system that we've just discussed. That's the brains of my system. And then from there, that is wired. You can just see these wires on the right. They're the wires coming out the back of it. They go into two key areas. The first place that they go is here, the programming track. So it's one pair of wires. You can just see at the back the wires going down there. So there's a positive and a negative wire go into the programming track, and they go into a terminal on the back of the controller that's been specifically designated for the programming track. It is actually labelled. The other two wires actually go to the main layout. You can see over there. So the red and the blue wire, positive and negative, go over there, and they hook into my bus wires, and that gives layout its power, allows me to run the trains. Okay, so what's a bus wire? Well, very simply, a bus wire is actually a pair of wires. It's two separate wires, a positive and a negative wire, and they run from the start of your layout all the way around the entire layout, wherever you need to go, all the way down to the end by the helix. I have two levels as well, so there's a bus wire underneath on the base level. It then runs over there, comes back on itself, goes all the way along to the top and back round to here. However, it's not a continuous loop. If I was to take it out, it would be a single length of two wires. You can see here it's cut. It doesn't actually join back in. It's not a ring. So to hook the power up to the track, I have various droppers, as they're known. So they are small pairs of wires soldered to each pair of rails in various locations around the layout where I will need power. So a good example would be over here. You can see we've got a long, continuous, straight piece of track. So somewhere along here there is a dropper just giving it some juice. However, here we have a point. So what we've got is some droppers here giving the track some power. That then comes along here, but depending on which way the point is switched, those that are familiar with DC will know where I'm going. If the point is switched, it's going to not send any voltage to one of these two tracks, depending on which way it's going. So you see at the moment we're turning right, so the electricity is going to flow into the right and go up here. This area is going to be dead. So anywhere that might get dead from points, anywhere that needs power, you have a pair of droppers soldered. Those droppers go through holes in the baseboard. I'm just over on the left-hand helix. So you can see the droppers there, soldered to the track, through the baseboard, and they go over there and they clip into the bus wires. So that brings me to probably the most frequently asked question I ever get, and that is, what on earth are these blue plastic things that allow you to clip wires to the track without using a soldering iron? Okay, so the blue things are called crimp blade splicers, and the red connectors that slot into them are just called Spade Connectors. I get both of those things from Rapid Electronics. If you haven't been to Rapid Electronics before or bought anything from them in the past, very good supplier. They supply sort of in bulk, so basically the more you buy, the cheaper it gets. I bought loads of stuff from them, ranging all the way from integrated circuits, pickaxe programming boards, MOSFETs, resistors, LEDs, you name it. You can get pretty much anything you need from Rapid Electronics. Okay, so the Spade Connectors, they're part number 33-1057. Can't guarantee these are still the correct part numbers because I've had both of these bags for a very long time now, a couple of years, but I doubt they've changed the order code. The crimp blade splicers, they're 33-0190. Again, I'm guessing the part number is still the same for these, but I can't be entirely sure. So the power from the DCC system comes along these bus wires, it goes into the crimp blade splicer and through the connector, and then it goes up to the feeders in your track, and that powers your trains. With droppers that connect up to the rails. With some careful soldering and a small hole and a little bit of weathering, they can be pretty easily hidden. With normal running you don't notice. So for example, there is one just here. See? That's probably one of the most exposed ones that I've got. I was looking for some others but I couldn't see them, but they are there. So to power other things like lights, point motors, signals, that sort of thing, you can't really use your DCC system because the DCC is rather busy controlling and driving all of the trains. Most of the power that the system is outputting is going to go to driving the trains. So what I have is a separate set of bus wires running at 12 volts DC that I use for various accessories. Now if your DCC controller has a 12 volt accessory output on the back, by all means use it. My lens doesn't have that feature, so I have to use a separate power supply, and generally that's what most people will do. They'll use a separate power unit, and that can be anything from a power supply you bought from somewhere like Rapid Electronics, or you can use an old Hornby DC controller. I use my old Gauge Master controller I used to have for the old layout, might as well reuse it, no need for it now. So that's running all the accessories at the moment. So probably the most demanding accessories I have on the layout are the point motors. So there's one in action. I use SEEP PM1 point motors with the built-in polarity switch. If you want to know more about the point motors and how I install them, then I recommend you watch my how-to video I made on installing a point motor. Point motors get their power from the accessory bus that's wired up to the 12 volt supply. So you see up here we've got positive and negative bus wires. These are the ones that power the track. And then underneath there's a separate pair, and it goes exactly the same route as the other bus wires do, follows it all the way along, and that powers the accessories. Here's the source of the power. This is just an old Gauge Master D controller. I'm pretty sure they still make it. It has a 12 volt DC output on the back, which is very useful. So I just got positive and negative wires going up into the bus wires, and they then power all of the point motors. The rest of the point motor wiring, such as polarity switch, goes into the DCC bus wires, so when the polarity is changed, when the point motor flips one way to the other, it keeps the voltage the right way around and feeds the point properly, and that way I don't have to rely on the point blades to conduct electricity, which makes the running of the layout a lot more reliable. But as I said, if you want to learn more about the point motors and how I install them, then I'd recommend you check out my installing a point motor video. The actual locos on the layout are all a mixture of 8 or 21 pin DCC locomotives. Now the only difference between 8 pin and 21 pin is purely the number of functions that you can have. So for example, an 8 pin decoder, they're typically free function, so an 8 pin decoder will do things like your ordinary running lights. You'll be able to turn on and off the cab lights, and you can do one other function as well. The 21 pin decoders are capable of a lot more because they have a lot more pins, so you can have a lot more combinations of code for various functions. So they can go right down to simulating when the engine runs out of fuel, all the way up to all sorts of other crazy stuff. 21 pin, to be honest, is a little bit overkill. I use very few of the functionality that you actually get with a 21 pin decoder. As far as I'm concerned, as long as the loco has lights and you can adjust the CVs, then I'm more than happy. The decoders I use are exclusively Bachmann. There's a lot of people that make decoders. Some are very good, some aren't so good. There's all sorts of different manufacturers out there. Here's some of the lighting accessories on the layout. These are just some plastic Hornby buffer stops with a red LED inside, just to sort of enhance the way they look. I also made a how-to video on this, so if you've got some Hornby buffers lying around, then feel free to check out my video and maybe you can liven them up a little bit with an LED. Now finally we'll come over to the last bit of electronics I have on the layout. This differs quite a lot. It's something I'm experimenting with and it's something that I've been working on, so you know, feel free to switch off at this point. But some of you may know I have some signals that I'm installing on the layout. Still only got the one at the moment, still haven't got around to installing some more. I need to order some more free aspect ones because I only had one to start with, and they're all made by Traintronics. They come with various accessories and bits and pieces, and they're also unpainted. I haven't done anything to this yet, this is just bare. We'll have extra detail added to it soon. To run the signals I have another pair of bus wires. Now the reason for that is I have my own little electronic circuit that I've developed. Took me absolutely ages, but I have got it working. This is an old prototype, but this is basically how it looks. This circuit works off 5 volts, and it's very fussy about that because it's component electronics, works off exactly 5 volts. Now the problem with the Gauge Master controller I have over there is it isn't regulated. So it says on the back it outputs 12 volts. I've measured it and at times it's outputting 14. It doesn't stay the same, hence why it's not regulated. So to get the signals to work properly, I had to buy a regulated power supply, which is down there. This is a power supply from Rapid Electronics. I think it cost me about 80 or 90 quid. It's capable of fixed 15 volts, 12 volts, 5 volts, -5, -12, -15. So that's quite useful if you want to use things like op amps and develop amplifiers and stuff for various accessories. It's a really good power supply. I used this when I did my electronic A-levels. I used it for 2 years doing my A-levels, and I really enjoyed studying that. And these power supplies were really good that we had in the class, so fortunately they still make them, so I bought one. So that runs through this tangled mess of bus wires. It's just a temporary pair of bus wires at the moment. You can see the droppers there, and it goes up into the circuit board under the layout, and it powers the signal. Just very briefly, the signal has an infrared pair of LEDs in the track which detects the presence of trains, and then there's a built-in timer, and there's a reset and manual override and various other features I've incorporated to the circuit, and so far it's working pretty well. Had it up here for a few months now and haven't had too many issues. So I hope that was somewhat useful and hopefully answered some of your questions. If you have any more questions, please feel free to post them in the comments section. I'll try and get back to as many comments as I can, but I do get a lot, so don't be offended if I'm a little slow in responding to your request. But that is basically how I get the power to the layout. What powers my accessories, what powers my signals, what controller I use, decoders I use, how the droppers work, and a few other bits and bobs. So hopefully that was useful for you, and I'll be back soon with another video.